Alright class, you just saw this problem done in class, but in case you weren't here, even though I think we had a perfect attendance today, but if you want to just double check how we did this again, you can watch this video. I'm going to kind of do it quickly though, so since you've seen it once. Again, the key is these the equations at the beginning. First of all, it says let x and y be the variables, x for vitamin A and y for vitamin B. So, first thing I'm going to do is come up with some equations. Alright, the first one. Body can tolerate no more than 600 units per day of vitamin A, so that means x has to be less than or equal to 600. And I'll make that orange. The other one is, for vitamin B, cannot be more than, so y has to be less than or equal to 500. And I made that red on my grid. Now, for this one, you can make it one big inequality, but we want two separate equations to graph the lines. We want x plus y has to be bigger than or equal to 400 because it says it has to be between the two numbers. Inclusive means you include it, so that's why we have the equal to. We also have x plus y has to be less than or equal to 1000. So those are our second ones. I believe that this was blue and this was green when I did this in class. Alright, and finally, due to the combined effects of the drugs, or not the drugs, the vitamins, the number of units per day of vitamin B, which is y, must be more than 1/2 the number of A. And finally, less than or equal to, y has to be less than or equal to 3 times the number of A. So these are our final two equations. Okay. And so these 6 equations are what you have to graph on your big grid. I did that in class, and you should have that hopefully down already. But let's look at the next part of this problem. This is the important part, coming up with your cost equation. CB, the number of cents per day. Write an equation expressing C in terms of y and x if vitamin A costs 0.06 cents per unit. So 0.06x plus 0.05y. This is our objective function or our cost that we're going to try to minimize or maximize. We already did part B, and I'm going to now show you the graph. Alright, here is the graph with all 6 lines and the shading false for every one. When you get the grid, it's important to try to find the points that each of these intersections happen at. Most of them you can do just by looking at it and remembering what your equations of the lines were. For instance, we know that this one has to equal 400, right? Because the blue line adds up to 400, and this is where x is 100. So the point 100, 300 is one of the points. And again, that works in the blue line because it adds up to 400, and the black line was y is equal to 3x. So sure enough, is 300 equal to 3 times 100? Yes, it is. So that one works too. Same thing up here. We can set this equal to y equal to 3x, and we know what x is. Well, we know what y is. Y is for sure 500 because it's the horizontal line. So if you do y is equal to, or 500 I should say, is equal to 3x, you get 500 thirds for x. So you can say that this is 500 thirds, comma, 500. Down here, we know y is 500, and we know the green line, this has to add up to 1,000. X plus y is 1,000. So this is the point 500, 500. Same thing here. We know the orange line, x is 600, and again, the green line, they have to add up to 1,000. So this point would be 600, 400. The purple line, y is 1/2 x. We know x is 600. That means y has to be 300. So 600, 300. And this is the one where you have to either set the equations equal to each other. This is the blue line, x plus y is equal to 400, and the purple line, y is equal to 1/2 x. So you can do y is equal to negative x plus 400 and set that equal to 1/2 x and solve that. Okay? When you solve that, you get 266 2/3, and you get 133 1/3. So now the question on the next sheet of paper, let's finish up the next sheet. What does a point lying in the solution set represent in the real world? Well, hopefully you guys realize we were graphing vitamins, the combination of vitamins. Combination of vitamins A and B. In class, I said let's not even worry about this. We would have to set up our cost equation by setting these costs equal to these and then graphing all those lines. Again, we're not going to talk about this right now. We will also not talk about what word describes the point. We're just going to write the coordinates of the point of the minimum cost. Again, you can kind of do this by looking at your graph. There's really only 2 points we have to check here. Hopefully you guys see that this one and this one could maybe be our minimum points, because as we go over here, all these values are much bigger. So when we put these into our cost equation, you guys should see that they're going to be costing a lot more to have 600 and 300 versus 100 and 300, for instance. And same thing with the 500 thirds and 500. So it's like about 166 and 2/3 actually is what that is. So again, 166 and 500 is a lot bigger than 100 300. The only thing we don't know really is these between these two. Which one of these would be the minimum point? And remember, we cannot use 266 and 2/3 and 133 and 1/3. We have to slightly go over and up to get in here more. So if we go over 1/3 but I go up 2/3, I should be in my solution set. So the point I'm going to actually test is 267 and 134. Okay, I'm going to test that point. So we now are going to just test the cost. So the one cost is going to be 0.06 times 267 plus 0.05 times 134, and you get approximately 23 cents. If I do the cost of the other point that we have, which is 0.06 times 100 and 0.05 times 300, you actually end up with a 21 cent cost. So the minimum is 21 cents, that's our min cost, and it's when we have 100 of vitamin A and 300 of vitamin B. Okay, again, we just did this, hopefully you guys understand it, but it is now up for you guys to double check your answers with.